In this video, we'll look at some examples to find all asymptotes and intercepts. We'll also graph the function. So our function is g of x equals 2x plus 5 divided by x minus 1. First, we'll find the vertical asymptote. To find a vertical asymptote, we set the denominator equal to 0 and solve for x. So our denominator is x minus 1, and when we add 1 to both sides, we get x equal to 1. This is where we have a vertical asymptote. Labeling the vertical asymptote on the graph, it will be at the value of 1 on the x-axis. And I'm going to draw a dashed line for the asymptotes. So this is where our vertical asymptote is located. Next, we'll find the horizontal asymptote. And we always compare the degree of the numerator to the degree of the denominator. The degree of the numerator is 1, and the degree of the denominator is 1. These have equal degrees. Looking at the rules, when the degrees are equal, we look at the fraction found from the leading coefficients. The leading coefficients are 1 and 2, so the fraction turns out to be 2 over 1, or just 2. So on the y-axis, at 2, we have a horizontal asymptote. Next, we'll find the oblique asymptote. An oblique asymptote occurs when the degree of the numerator is 1 more than the degree of the denominator. Well, in our function here, the degrees are the same, so we do not have an oblique asymptote. Next, we'll find the x-intercept. To find an x-intercept, set the numerator equal to 0. So we have 2x plus 5 equals 0. And solve for x. Subtract 5 on both sides and divide by 2. So the x-intercept turns out to be negative 5 halves. And the point is written as negative 5 halves, comma 0. Negative 5 halves is about negative 2.5 as a decimal. So on the x-axis, at negative 2.5, I'm going to put a point for the x-intercept. Finally, we'll find the y-intercept, and to do this, we'll plug in 0 into the function for every x value. This will give us 5 divided by negative 1, or negative 5. The point for the y-intercept is 0, negative 5. So the function will cross the y-axis at negative 5. Now we'll use our calculator to finish up this graph, see where the function goes. When we enter in our function into the calculator, we always need to put parentheses around the numerator and parentheses around the denominator. Now this is a very important step because if you leave off the parentheses, you will not get the right graph. So we'll enter it in like this, parentheses around the 2x plus 5, and then we'll divide with parentheses around the denominator of x minus 1. First, I'm going to graph it using the TI-83 calculator because the 83 and the 84 graph the functions a little bit differently. I'll show you both calculators. So first, I'll press the y equals key, type in 2x plus 5 divided by x minus 1. I'm going to press zoom number 6 and use a standard window. Alright, so you see how the function is decreasing and it crosses right here for the x-intercept and it crosses again down here for the y-intercept, and the vertical line here is actually the vertical asymptote. It really should not be there because it's imaginary. And then you see the function on the right side decreasing as well. So when we draw our graph, we'll go ahead and sketch it going through the intercepts down to the vertical asymptote. And then on the other side, the graph came over like this. Now I'll show you how to graph the same function using the TI-84 calculator. Press a y equals key. We'll type in the numerator and divide by the denominator. I'm going to press zoom number 6. And I'll bring up the TI-83 and we can compare the two screens. Notice that the TI-83 does graph the vertical asymptote, but the TI-84 does not. Notice the graphs have the same shape. The only difference is the vertical asymptote. Technically, the TI-84's graph is more accurate than the 83 because keep in mind that a vertical asymptote is really imaginary. But there's a look at that function and how to find each part. I'm going to work one more function for you. The next function is f of x equals x plus 4 divided by x squared minus 2x minus 3. Now this function can be factored. If we take a look at the denominator, we need to find two numbers that multiply to negative 3 and add to negative 2. Those numbers are negative 3 and positive 1. So our factors turn out to be x minus 3 times x plus 1. Nothing cancels out. So let's go ahead and find the vertical asymptote first. So to find the vertical asymptote, we'll take our denominator that's already factored and set it equal to 0. Then we'll set each factor equal to 0. So we have 3 for a vertical asymptote and negative 1 for a vertical asymptote. On the graph, I'll label each one of these. So those are our two vertical asymptotes. Next, we'll find the horizontal asymptote. We compare the degree of the numerator to the degree of the denominator. The degree of the numerator is 1. Degree of the denominator is 2. So 1 is less than 2. And by the rules, the horizontal asymptote is y equals 0 or the x-axis. Drawing this on the graph, we have a horizontal asymptote running along the x-axis here. For the oblique asymptote, we look at the degrees. The degree of the numerator is not 1 more than the degree of the denominator, so there is not a oblique asymptote. Next, we'll find the x-intercept by setting the numerator equal to 0. So the function will cross the x-axis at -4, and if we write it as a point, it is at -4, 0. I will label that on the graph. Finally, we'll find the y-intercept. To do so, we plug in 0 for every x. And we'll use the original function. So the y-intercept is at the value of -4/3. And the point is 0, -4/3. Go ahead and label the y-intercept on the graph. The decimal equivalent of -4/3 is -1.3 repeating, and that will be right about here on the y-axis. Now we'll use a calculator to fill in the gaps and see how the function works. Hit the y equals key. Remember to put parentheses around the numerator and denominator. And this is a look at the graph. You see how the function is increasing on the left. In the middle it increases and then it decreases. And on the right side it decreases off to infinity. So I'll go ahead and trace this on the graph. Our function comes up to the vertical asymptote. Then it skips over it and it's down here at the bottom and it increases up to the y-intercept. Then it decreases again to the other vertical asymptote. And then on the right side it goes down and then comes over to the right. I'll go ahead and graph the function in the TI-83 calculator. Make sure you do not forget your parentheses. And you see we get the same graph. It does look a little bit different with the vertical asymptotes drawn, but we basically have the same thing on the TI-83 and TI-84.